Oh my God. Hello, am I audible? Hello, can you hear me?
Yes, we can hear you.
Okay, let's get started with the session today then. I hope my slides are visible.
Yes.
Okay, thanks. So yeah, today we'll be discussing week 2 of the course. So first I'll be quickly revising whatever was covered in each of the weeks. And if you noticed, if you have already watched the lectures, at the end of each lecture, there was a problem that sir had asked you to solve. So we will also be discussing that. And I have shared in the chat box all of these 3 links. So every lecture will be recorded and uploaded to YouTube. You can get it from the playlist here. And all the presentations will be shared in this Google Drive folder. And this is the meeting link for the live sessions. I'll just put it in the chat box once again for your reference. Okay, and these links will also be available in the NPTEL portal if you want to access them anytime. So this was the first part of the lecture where some important concepts of vector operations were covered. Like for example, vector addition.
Actually, the slides are not visible now.
Oh, um, it's just okay. I'll share it again. 1 minute. I think now it is. Now it should be visible, right?
Yes, yes, now we can see.
Okay, thanks. So for example, if you have 2 vectors, I'm just giving some easy example. Then a plus b would be you just have to add these 2 terms and these 2 terms. So this would be 5 and 7. And the second operation is scalar multiplication. So it means that you're multiplying a vector with a scalar. So for example, 3 times a, that will be 3 into 2, 3. So here you just have to multiply each of the terms by the scalar. And the third operation is dot product. So this will be a dot b. So here you just have to multiply the corresponding terms. And finally, we also discussed about orthogonal vectors. So orthogonal vectors means the angle between the 2 vectors will be 90 degrees. And if this angle is 90 degree, for example, if this is a bar, this is something else, c bar, then the dot product of the 2 vectors will be 0. So these are some of the important concepts that were discussed in the first lecture of week 2. And now we can try to solve this problem, which was at the end of the lecture. So we have to calculate the angle between u and v. So you can take a couple of minutes to solve this problem and you can type in the chat box so that you have some time to go through this. Then we can discuss it. Yeah, so most of you have got it right. The correct answer is 90 degrees. So you can um, see that in the question itself, they have mentioned that these two are orthogonal, which means that they are 90 degrees to each other. But you can also check it with the dot product formula. So the formula for dot product is u bar dot v bar equals mod v into cos theta. So here mod u is the magnitude of u and mod v will be the magnitude of v, and this theta will be the angle between u and v. And this u bar dot v bar we can calculate from these two values here. So this you just have to multiply the corresponding terms. And this is basically 2 plus minus 2, so it will be 0. And we know that these two values are not 0. So this value is not 0. So this cos theta has to be 0. Or theta equals 90 degrees. So the angle between u and v is 90 degrees. This is the final answer. I hope it's clear to all. Does anyone have any questions? Okay, so if there are no questions, we can then move on to the next week's content. So in the next week from vectors, we moved on to matrix. So um, so if A is a matrix, then it can be written in the it's written within these square brackets. And there are different types of matrices. For example, this is a square matrix because here number of rows equal to number of columns. You can also have a rectangular matrix. So here this is 3 and this is 2. So it's a rectangular matrix. Number of rows and number of columns are not equal. And zero matrix means all the terms are 0. and so on. And similarly, like just like the vector operations that we did, like addition and multiplication and so on, here also we can do the same similar kind of operations. So for example, if you but here if you want to do these operations, like for example addition, then you can only do it if the matrix size are equal. So addition is again just like the what we saw for the vector case. It will be a term by term addition. So here we have to add 2 plus 5 and here 4 plus 7 and here these two corresponding terms 3 plus 6 and these two corresponding terms 13. So these are some of the important concepts from the second lecture of week 2. Now let's discuss the problem. So you can take a couple of minutes to solve this and then we can discuss the solution. Yeah, I think my mic was off. So does anybody have any questions in this?
Oh, again, we're not able to see the screen.
But for me, it is showing that the slides are shared. Are others also facing the same problem? Because in my Teams, it is showing that the Teams presentation is being shared. Okay, it's visible to the others. So if for some of you, if you are not able to see it, you can try to disconnect and then connect to the meeting again. Maybe then it will be visible. Okay, if there are no questions in this, then we can move to the next week's content. So here, this is one of an important concept to find the determinant of a square matrix. So again, let's take an example. 2, 3, 4, 5. But to get the determinant of A, you have to, so this is like an easy way. So determinant of A is, I hope my slides are visible now and you can see whatever I'm writing. Okay, so this is an example to calculate determinant for a 2 cross 2 matrix.
Ma'am, could you please?
Sorry, I can't hear you properly. Gia, are you there?
Can you please share the answer for the previous question?
Oh, okay. So here in the question, they are asking us, they have given us two vectors, and the first vector we have to stretch it, second vector we have to shorten it, and they have asked us to do it using matrix multiplication.
Okay, ma'am, thank you.
Did you have any questions or? Okay, let's go to the next week's content. So we were discussing how to calculate determinant for a 2 cross 2 matrix. And after that, in the lectures, we also discussed the geometric meaning of a determinant. So for example, if there are two vectors, maybe this is A and this is B, then the Yeah, I think I'm actually using my iPad to write on the slides and sharing it from the laptop. So I think whenever I write something, sometimes the screen sharing is turning off. So let me share it again. I hope now it should be visible. Yeah, so we were discussing about rank of a matrix, which is the linearly independent number of rows. So if you have a matrix, let's say 1, 2 as the first column, and maybe the second column is twice of this, so 2, 4. Here we say that these two columns are linearly independent because if you multiply the first column by 2, then you get the second column. So these two are linearly independent, and the rank for this will be 1. One more thing is for these kind of matrices where we have linearly independent columns, the determinant will be 0. But for a full rank matrix, meaning that the rows are not linearly independent, so it is something like this. Then here the determinant will not be 0. And we also discussed about inverse of a square matrix. So inverse means that if you multiply the matrix by the inverse, then you get the identity matrix, which is this matrix. And so you to get a inverse, we should not be any linearly independent rows. It should be a full rank matrix. So now let's discuss the solution to this. So you can take a couple of minutes to solve it, and then we can discuss the solution. Do you want more time to solve this, or can we discuss the solution now? Just let me know if you need more time. I can wait for another minute. Okay, I'll go ahead and discuss the solution then. So this term is 0 and this term is 5. 0 minus 5 is minus 5. And to get A inverse, we can use the formula. So that's it that they have asked in the question, the rank, determinant, and the inverse. If there are no questions, we can go to the next week's. Okay. So in the next week, we discussed this important concept of eigenvalues and eigenvectors. So the eigenvalues and eigenvectors, they have to satisfy this equation. So if this is a vector and when you multiply it by its eigenvector, then you will get a product which is like a scalar times of the eigenvector. And this scalar, this lambda, it is a scalar which is the eigenvalue. And this vector that we are multiplying it with, this is the eigenvector. Um, and obviously it cannot be zero. I mean, when you multiply it by a zero vector, you will always get zero, but eigenvector should not be zero. And one more important thing is it's only defined for square matrices. We can't define it for rectangular matrices. And for a square matrix which has n rows and columns, like maybe 2 cross 2, then the maximum number of eigenvectors will be 2. For a 3 cross 3, then the maximum number of eigenvectors would be 3. And we also discussed about symmetric matrices. So for a symmetric matrix, then the vector and its transpose will be the same. So I hope all of you know what does transpose means. So when we have to do transpose of a matrix, we have to interchange the rows and columns. So a simple example of symmetric matrix would be the identity matrix. So when you transpose it, this will become the row. So this will be 1, 0, 0, 1, and these two values are same. So it's a symmetric matrix. So now let's discuss the question that we were asked to solve. So you can do this with an online eigenvalue calculator tool. So I'll just copy paste the link in the chat box and you can take a couple of minutes to try it by yourself. Then we can discuss the solution. So in the question, they have asked us to solve it by taking like considering an example matrix. For example, maybe for the we can consider this matrix. And then I have put this link in the chat box, so I'm putting it again in case anybody missed it. So by entering the values of this, you will get the eigen values of this matrix, or they have said M. And then find the lambda for this. And then we have to find M square and we have to find the um, lambda for these as well using this online tool. Okay, so now I hope you had enough time to solve it. Otherwise, I'll be solving it now. You can solve it with me. So I have to let me go to that online tool. So now I think my browser should be visible. So here we have considered a 2 cross 2 matrix and the matrix is 2, 3, 4, 6. And let's calculate the eigenvalues. So we have got two eigenvalues, 0 and 8. These two are the eigenvalues. And in the question, we have to also find the eigenvalues of the um, square of this matrix. So we also have to input those values. So let's calculate the square of the matrix. So I'm calculating the square in the presentation itself. I'll just go and share the presentation. Just give me a minute. Because I think right now you should be seeing my the online calculator. I'll share the presentation so you can see how we can calculate the square. And the second term will be this plus this, so 6 plus 18. And the third term would be these two terms multiplied and added. So 8 plus 24. And the final term would be 12 plus 48. Thirty-two and 48. So now this is m square, and these for m we have found the eigenvalues. Now we have to find the eigenvalues for m square. So let's go back to the calculator. I'm just typing the values for m square that we got. And these are the eigenvalues that we get. That is 0 and 64. So we can see that this is a square value. Square of 0 square is 0 and 8 square is 64, which is what they have asked to take in the question, that lambda is the eigenvalue for m and lambda square is the eigenvalue for m square. So we have verified this. So now let's go to the next week's. So next week we discussed about solving a system of equations using matrices. For example, if we have, I'm just explaining this with an example. Then this can be represented as, so these coefficients will be in the A matrix and the variables will be in the X matrix, and B will be these values. So this is A, this is X, and this is B. So any system of equations, we can represent it as Ax equals B. So M cross N matrix. That is, so for example, this has, and this is, in this case, it is a 2 cross 1. And here M cross N means here it is a 2 cross 2 matrix. So this N is the number of variables. So here we have, and this M will be the number of equations. So here we have two equations and two variables. So if that is the case, if number of variables and number of equations are the same, and if this determinant is non-zero, then we have a unique solution. But when m is greater than n, or if we have less number of variables and more number of equations, then it is overdetermined and we are unable to solve it. So we won't have any solution. So for example, if you have or if you have two equation and three variables, so here you won't have any solution. But in the opposite case, when m is less than n, we have three equations, two variables, then we'll have infinite solution and it will be underdetermined. So these are some of the important concepts of using matrices to solve a system of linear equations. So now let's discuss the related problem with this. So to solve this, we have to use the concept of Ax equal to b and x equal to A inverse b. And then to find A inverse, we can use this tool. So let me just put this in the chat box and you can try it by yourself. So I hope now you have the link to the inverse calculator. So the first step will be to write the system of equation in this form as Ax equals b. So maybe I'll help you until writing it in this form. Then finding the A inverse and these two steps you can try on your own. So these are the equations. But in the second equation, there is no y term. So this can be written as 0 into y. So when you convert it into this form, you have to make sure that all the variables are there and they are in the correct order, like x, y, z, x, y, z. It should not be like So even if it is of this form where y is coming first you have to convert it so that x, y, and z are in the correct order in all the three equations. And the third equation we can write just like that. So when we convert it, it will be, this is 1 into x, 2 into x, and again 1 into x. So this will be 1 to 1. This will be 2, 0, and 1 into y. This will be 1 into z minus 2 and 2z. So 1 minus 2 and 2. And here the variables we have to write in whatever order. X is first, y is second, z is third. So we have to write here in the same order. And finally, these three numbers. And now you can use this tool to get the inverse of A. So let's do that now. I hope you're following and doing it along with me. So this is a 3 cross 3 matrix. I'm typing 3. And the values are 1, 2, 1, 0 minus 2, 1, 1, 2. Now let's calculate it. Now we have to use this to solve the equation. Let me go back to my slides. Yeah. We are trying to get the value of A inverse B, and this value we got from the online tool. Which is, I'm just writing it here. And this is the B value, this one. So I'm just copying it here. I'm just substituting the values basically. So the final answer will be we have to multiply these terms. And so the second row we have to multiply these two. And similarly, third row we can find with this. And this value will be XOX is XYZ. So X value will be minus 5 by 4. plus 3 by 4 will be 0.75. 5 by 2 will be 2.5. Y value will be 15 by 4 is 3.75 minus 0.25. So this will be 1 by 4, so 0.25, and minus 5 by 2 is 0.25, 2.5, sorry. And Z will be 5 by 4, which is 1.25. Yeah, 1.25 minus again 2 by 8 will be 0.25, 5 by 2 will be 2.5. So this will be 2.5 plus 0.75, 3.25 minus 1.25, and Y would be 3.75 minus 0.75, which is 3. This will be 1.25 plus 0.5, 3.75 minus 0.25. Yeah, so we have just used this A inverse B formula to solve the system of equations. And to get A inverse, we use the online calculator. And then we have multiplied it by B, and we have done some calculations to get the final values of X, Y, and Z. So these kind of matrix multiplication, if you solve more, then you'll be more comfortable in doing it. So you can, if you, whenever you have the time, you can try to solve more problems, especially for matrices, because with practice, you will get comfortable in doing these kind of problems. But I hope this problem is clear to all. If you have any doubts, you can just unmute and ask, or you can also raise your hand. Because this is an important concept, using matrices to solve system of equations. So I hope this concept is clear to all. Okay, if there are no more questions, now I think almost 1 hour is over. So we have to be a bit fast now. But yeah, we have almost covered all the lectures. And yeah, in the next lecture, we discussed about eigen decomposition and singular value decomposition. So in both of these, we are writing a vector in a simplified form using different kinds of vectors, like using specialized vectors. So in eigen decomposition, we are writing it in this form, V inverse. And singular value decomposition, we are again, if it is a single A, then we are writing it as these three vectors. And each of these vectors have special properties, that this is a diagonal matrix. And the diagonal matrix means these terms will be 0. Only the diagonal values will be having non-zero, this main diagonal. All the other terms will be 0. So that is a diagonal matrix. So singular value decomposition means you have to write it in this form, where this will be a square matrix, this will be a diagonal matrix, and this will be another square matrix. So basically, you are breaking down a vector into these and writing it as this form. So now let's discuss some of the additional problems for this week. So you can take a minute to solve it. It's a simple problem, just vector addition. And you can type the answer in the chat box. Then we can discuss it. Yeah, so some of you have typed the answer, so I think you had some enough time to solve it. So W, so vector W is the sum of vector U and V. So we have to sum these two vectors, 2, 3 plus 0, 1, 5. And this will be 1 plus 0 is 1, 2 plus 1 is 3, and 3 plus 5 is 8. So the correct answer is option B. So do you have any doubts? I'll just wait for some time if you have any doubts. If not, we can go to the next question. So this is a matrix multiplication question. Here I'll wait a couple of minutes. Then once some of you have got the answer in the chat box, then we can discuss it. So I hope all of you are having a pen and paper to solve these problems. Yes, Kumar, you have raised your hand.
Sorry, ma'am. By mistakenly, I clicked on raise button. Sorry,
Oh, okay,
sorry,
okay.
ma'am.
No problem. Okay. Okay, so I can see that people are starting to put the answer in the chat box, so I'll start solving it now. So it's matrix multiplication basically. So this is again very important, matrix multiplication. So I hope you can do it on your own. If you have any doubts, then you can follow it along with me. So we have to multiply these two matrices. The first term would be we have to um, take these two values and then these two plus these two, and all of these basically, and then add them for the first term, 2 into 0. And similarly for the second term, we have to add the this row with this column, these two and these two. So this would be 0 into 2 plus minus 3 into 1 plus 1 into 0. So the final answer is, we just have to do this addition now. 3 sorry 1, this term is 2, not 3. I made a mistake, so I've corrected it. 0 minus 3 plus 0. So 2 minus 1 is 1, 0 minus 3 is minus 3. So the correct answer is option C. So I hope this matrix multiplication is clear to all. Does anyone have any questions? Otherwise, we can go to the next slide. Okay, if there are no more questions, we can move ahead. So this is based on this week's. So to determine whether it is overdetermined or underdetermined, so I'll just give a hint quickly. You have to compare the number of equations and number of variables. So based on that, you can try to answer this question. So I'll give you a couple of minutes and then we can discuss it. Okay, some of you have typed the answer in the chat box. So here uh, we have 1, 2, 3 equations and x and y. So two variables. And if we go back here, um, yeah. So in this case, we are having number of equations 3 and number of variables 2. So it is a case of m greater than n. So it's an overdetermined system. So here m is greater than n, so it is overdetermined. So the correct answer is option A. Or you can also get the m and n by writing it in matrix form. So Ax equals B. 1, 2, 3. And this is a m cross n matrix. This will be x and y. So this is a n cross 1 matrix, and here there are 1, 2. So n is 2 rows, and here there are 1, 2, 3 rows. So m is 3. And another way to get m and n is just number of equations, and n is number of variables. And m is greater than n, so it's an overdetermined system. So option A is correct. Anybody has any doubts, or can we go to the next one? Okay, let's go to the next question. You can take a couple of minutes to solve it on your own and type in the chat box, then we can discuss the solution. Okay, so people have started typing the answer, so I hope you had enough time to solve it. Now we can discuss it. We can check all the options, whether they are meaningful or not. Option A is dot product of A and B, and the whole thing dot product with C. So when we do a dot product of two vectors, we get a scalar So, and dot product with C, but C is a vector. So it is not possible to do scalar and vector dot product is not possible. So dot product is in between two vectors. So dot product is for two vectors, but here we are getting dot product of scalar and a vector, so it's not meaningful. So option A is not correct. And option B is dot product and of two vectors followed by product. So this is just a normal, this is not a dot product. Here, this bracket indicates just scalar multiplication. So A dot B will be giving us a scalar value multiplied by C. So this is fine because it's scalar multiplication of a vector. So for example, this is something like this. So when you multiply a vector by a scalar, you just have to multiply all the values. So option B makes sense, it is meaningful. And let's look at the other options. In option C, we are first doing a dot product and then doing an addition. But when this will basically be scalar plus vector. Again, this is also not possible because vector addition means you can only add vector plus vector. So you can't add vector plus scalar. So option C is also not correct. And let's go to option D. We are finding the determinant and then doing a dot product with B plus C. So this B plus C, this is vector plus vector. So this will also be a vector. But determinant of A will be a scalar. So again, we can't do a dot product of scalar and vector. So option D is also not meaningful. So the correct answer is option B. So this question is based on the concept that for a dot product, you can only do a dot product of two vectors. You can't do it with scalar. And similarly, vector addition also, you can only add two vectors, vector plus vector. So you can't add vector plus scalar. So you need two vectors for vector addition. So this is the concept behind this question. So the correct answer is option B. Any doubts? If not, we can go to the next question. Okay, let's move on then. This is also a question based on matrix multiplication. Okay, so somebody has typed in the chat box, so I'll go back and explain option B. Oh, just a minute, because there's no space. So option B is A dot B dot product followed by multiplication. So A dot B followed by multiplication. And here there is no dot, so it is a, so this bracket means these two are doing scalar multiplication. Because there is no dot or cross in between. And A dot B is a scalar. Because when we do a dot product, we finally get a scalar value. and C is a vector. So we are multiply vector by scalar. So this is allowed in matrices because it's just a scalar multiplication. So for example, want to, if you have a vector C is 2, 3, and you want to multiply it by a scalar, for example, 2, then you just have to multiply all the values here. So 2 times 2 is 4, 2 times 3 is 6. And geometrically, what it will do is, if this is 2, 3, this is the vector 2, comma 3. When you multiply it by a scalar, here the scalar is 2. So the final vector will be double. So that is the meaning of scalar multiplication. It will just scale up or scale down the vector. So I hope option B is clear now. Okay, let's go to the next question then. You can take maybe 1 or 2 minutes for this, then we can discuss the solution. Just once you have the answer, you can type in the chat box. So let's discuss this question now. Here we are multiplying two matrices mm, equals A, B. And so in the question, they have given that A is a 2 cross 3 matrix and B is a 2 cross 2 matrix. So finally, when you multiply um, M cross N matrix with then finally you will get these two will be the final number of rows and columns. So when you're multiplying 2 cross 3 matrix with 2 cross 2 matrix, then you will get a final matrix which is 2 cross 2 or rows and columns. So and they are asking number of rows in C. So number of rows will be 2. Okay, so let's go to the next question then. So this is a easy question, so I hope you can quickly put the answer in the chat box. Then we can discuss the solution. So here they have asked us to um, represent the data for gene C as a vector. And so each of the values from the 3 experiments for gene C we can consider as each axis of the vector. So it will be 1, 2, 3.5. So you just have to write these values into a vector form. So the correct answer is option B. So this is a simple question. I hope it is clear to all. Let's go to the 7th question. please take a couple of minutes to solve this and write the answer in the chat box. Then we can discuss the solution. And when you write the answer in the chat box, write the question number and the option both. So then it will be easy for me to understand which question you have answered. So let's discuss the seventh question solution now. It is given that W is a 4 cross 6 matrix, so it has 4 rows and 6 columns. And option A is it is a square matrix, so it's not correct because uh, it has 4 and 6 rows and columns, so these two are not equal. So option A is not correct. Option B is about W inverse. But we know that inverse is only defined for square matrix. So W is not square. So W inverse is not defined. So option B is also not correct. And next question is about, option is about W transpose W. So W is a 4 cross 6. And so W transpose means rows and columns will be exchanged. So will be 6 cross 4. So W transpose W will be, this will be 6 cross 4 and 4 cross 6. So finally it will have 6 and 6. So 6 rows, 6 columns. So W transpose W, this will be a square matrix. Sorry, I'm writing on this slide actually. Yeah. So this is option C. So yeah, W transpose W is, as we can see here, it is a square matrix. And when you multiply a matrix and its transpose, we always get a symmetric matrix. So it's a square symmetric matrix. Option C is correct. And now let's look at option D. So option D is about eigenvectors. So W is a 4 cross 6 matrix. So we can't define eigenvector because eigenvector is only for square matrix. So option D is also not correct. The correct answer is option C. Does anyone have any questions on this? Okay, if there are no questions, we can go to the final question of today. So they have given a matrix, and out of the four options, we have to find out which is the eigenvector. So to do this, we can use the, I'll just give a hint, then you can try to solve it on your own. To use this, you can use the definition of eigenvector, which is A into V bar is equal to lambda into V bar. So this A here is this matrix which has been given. And this V here, you have to substitute the options. So basically, you have to multiply A and V for all the options and see whether for any of the options you are getting lambda times or scalar times V bar. So you can take some 3 to 4 minutes because you have to find vector multiplication for like 4 possibilities. So you can take 3 to 4 minutes. Then we can discuss the solution. Has anyone got the answer for this? Or do you need maybe a couple more minutes to solve it? Okay, I'll wait for another minute, then I'll discuss the solution. So for each of the options, I'm multiplying the vector A with the each of the option to find out which of these is the eigenvector. So if you multiply option B, get 1 plus 2 into 2, 4, and 0 into 1, 0, plus 3 into 2, 6. This will be 5, 6. So this also we can't, so 5 and 6, we can't try multiply as 1 and 2. Because for example, if you want to get 6, then you have to multiply by 3. So you'll get 3 and 6, not 5 and 6. So it's not, we can't write it in the form lambda v. And now if we multiply option C, this A value with option C, 2, comma 3, we get 1 into 2 plus 2 into 3 and 0 into 2 plus 3 into 3. So this will be 8 and 9. And this also, if we want to get 4, sorry, if we want to get 8, we have to multiply by 4. So 8 and, but we'll be getting 12, but here we are getting 9. So it can't be written as lambda v. And the last option is 1, 0. So when you multiply by 1, 0, you get 1 plus 0. And 0 into 1 plus 3 into 0, this is 0. So for option D, you're getting A into V is equal to 1, 0. So lambda is 1 into V bar. So the last option, option D, is satisfying this. So the correct answer is option D. I hope it's clear to all. Any questions? Okay, so that's it for today's sessions. If you have any doubts, you can ask. Otherwise, we can finish the session for today. Okay, so I hope it was clear to everyone. So I'm ending the session for today. See you next week.